Right, I want to do another example of solving a system of equations in 3 variables, and this one I tried to pick one that's a little bit harder. Also, I picked one that I haven't done myself yet, so that you can see my thought process as we go. So the reason this one is harder is because there really isn't a good variable to pick. We're going to have to do some work no matter what. So I could almost like, I really could literally say, okay, let me put these 3 variables into a hat and let me pick out which variable I'm going to cancel out. So instead of doing that though, I would like to pick the x's because I can see that, oh, 5x is positive, the other 2 are negative. So that gives me maybe an option to pair up. But actually maybe not. Like, I would like to pair up the first 2 equations and eliminate my x's. Okay, the first 2 and eliminate my x's, and then I will pair up the second and third one to eliminate my x's because that one's going to be fairly easy to do. Okay, so if I say on these first 2, I want to eliminate my x's, that means I want the same number in front with different signs. They already have different signs, so I need to think about what number could I get these both to equal. Well, one way to do that is to start with the bigger number and think about the multiples, because nothing times 2 gives me 5, nothing like normal fractions, I'm not counting. Okay, nothing times 2 gives me 5, but the first multiple after 5, which is 10, there is something I can multiply 2 by to get 10. I can multiply it by 5. So that tells me that I can shoot for 10 for these 2 equations. So the top equation, to get a 10 in front of x, I have to multiply by 2. The second equation, to get a negative 10, I'd have to multiply by 5. So I'm going to distribute all the way through on both of these. Okay, and then I'm going to distribute the 5. Okay, and we have to be careful. This is a really easy place to mess up, and if we mess up here, then we're not going to be happy later when we have to sift through all this and figure out what our mistake is. Okay, when I add these equations together, my x's cancel out. Negative 4y plus a negative 30y is negative 34y. Negative 12z plus a negative 20z is negative 32z. And 36 plus 0 is 36. Okay, so I have one equation that has x eliminated. Now I need to do that again. So I picked the second and third one to eliminate, and make sure that both times you eliminate the same variable, because I could try to eliminate y or z on my second go, but that doesn't help me because when I add those equations together, I'm still going to end up with 2 variables. So what I can do here is I can say, well, I can multiply 2 by 3, and that will give me 6. But it will give me this, I'll have the same sign unless I multiply by a negative as well. So I'm shooting for a positive 6 here, which means I'm going to multiply by negative 3 through the whole equation. That gives me 6x plus 18y plus 12z equals 0. Okay, so I can eliminate my x's. Negative 5y plus 18y is 13y. Negative 3z plus 12z is 9z equals negative 17. So now I have 2 equations that have a y and a z, so that I can eliminate one of those variables. I'm going to move this equation over here so I can get a better look. And this is gonna be kind of tricky, because like there's not really anything good to multiply either equation by. So this is gonna not really be fun. Because I know you were having fun up till now on this problem, but at this point it's gonna get a little sketchy. Okay, if I think about trying to eliminate y or z here, I'm going to have to basically multiply each equation by what the other one has. I'm going to pick my z's because they have smaller numbers. But basically, there aren't any lower numbers than whatever 9 times 32 is. Like, I need to multiply the top equation by 32 and the bottom equation by 9 to get something that will cancel out. And this is where I really enjoy having calculators nearby. Okay, because we've got some big numbers coming up. For example, 32 times 13 is 416y, and then 32 times 9 is 288z. 32 times negative 17 I know is going to be negative. Gives me 544. Second equation, 9 times 34 gives me 306, and it's negative. This should be minus 288, but just in case, yep, that's it. Minus 288z, and 9 times 36 is 324. Now I'm ready to add these equations together. Okay, 416 plus a negative 306 is 110y. My z's cancel, and negative 544 plus 324 is negative 220. Now I just need to finish solving this for y. So I'm going to divide both sides by 110. And that gives me y equals negative 2. Whew. We made it through that, okay? So even though our numbers got really big, because I used the calculator to make sure I was doing it right, and getting right numbers, it wasn't too bad. I ended up getting something that divided evenly, which I knew it should have. So y equals negative 2. Now we need to take this back and plug it in to one of our equations where we had y and z. Okay, now there's a whole bunch of them we could use, like this one over here, these two, even these two. But I figure the smaller the numbers are, the better, because that's less room for error, I feel. So I'm going to plug it into the 13y plus 9z equals negative 17. Okay, because that one has the smallest numbers out of all of them. So 13 times negative 2 is negative 26 plus 9z equals negative 17. I'm going to add the 26 over to the other side. I believe that gives me 9z equals 9. Divide on each side. So z equals 1. Now I just need to go back and plug into one of my starting equations, and I'll just pick the first one because there's not any of them that really is any easier. So 5x minus 2 times y, which is negative 2, minus 6 times z, which is 1, equals 18. So I need to go ahead and do negative 2 times negative 2 is a plus 4. Negative 6 times 1 is a minus 6. That's like terms. 4 minus 6 is negative 2. So I would add that to the other side. And that gives me 5x equals 10. Divide by 5. on each side, so x equals 2. Okay, so my problem answer is 2 for x, y is -2, and z is 1, and we're done. Okay, so kind of a long problem, but that's like a worst case scenario where we there wasn't anything easy basically to eliminate. So we had to do a lot more work and get a lot bigger numbers to get something to eliminate.